Today we're talking about centers of triangles and the special segments that make those centers of triangles. Okay, so it's a lot of vocab today, and we're going to work our way through it and make sure that we know how these things all work. So the first one that we're going to talk about is the perpendicular bisector. Now, perpendicular bisector would be hard to define without the words perpendicular and bisector. And I think you all know what the word perpendicular means. If two segments are perpendicular, what does that mean? They make 90-degree angles, okay? And if a segment is a bisector of another segment, what does the word bisector mean? It crosses through, but what does the word bisect? Not just cut into two lines, but what does it also do? Exactly in half, two equal portions, okay? It may not look equal, but it could be distorted because of our screen. But this is the perpendicular bisector of segment AC, okay? Which means that I'm looking for perpendicular marks. So we're looking for perpendicular marks, and we're looking for tick marks. Okay? Perpendicular marks and tick marks. If you see a perpendicular mark and you see tick marks, you know you have a perpendicular bisector. Write that down in your little box. Okay? The two things that you're looking for. You're looking for tick marks and you're looking for right angles. If you find those, you found a perpendicular bisector. Okay? Look for ticks and look for perpendicular marks. Okay? Right angles. Yep, these guys, the little double tick marks or single tick marks, we want to see that our segment has been bisected. It's been cut in exactly half, and we want to see that we have a right angle there. Okay, then we know we have a perpendicular bisector. Questions on this one? All right, next, we want to talk about angle bisectors. So an angle bisector we've seen before. It cuts an angle in two equal angles. Okay? So when you're looking for angle bisectors, you're looking for these arcs that are equal. Look for arc marks. Okay? Then you know you've got an angle bisector. It starts at the angle and it goes to the opposite side, but it cuts that angle into two exactly equal angles. Yes, sir? Absolutely. Only on special occasions. Okay? So if you have a special triangle, what kind of triangle is this? Isosceles in this case, right? Or if you have an equilateral triangle, then what happens if we drop that perpendicular here? I'm not doing a good job. We'll have a hypotenuse and a leg. And not only will that perpendicular bisector bisect the sides at a 90-degree angle, but it will also bisect the angles. Only with two special triangles, isosceles or equilateral. You list them all. Perpendicular bisector and angle bisector. Okay? But I won't try to confuse you. I'll try to give you things that are just one thing. Okay? Great question. Any other questions? All right, so we've talked about perpendicular bisector. We've talked about angle bisector. Next, we need to talk about something called a median. Okay? And you haven't been exposed to a median in geometry class. Okay? A median is something that does what on a street? Yep, separates it down the middle. It cuts the street in half, doesn't it? Okay? So a median is something that cuts a segment in half. But do you see a right angle there? No. So we still have the tick marks, but we don't get to have the right angles because it's not a perpendicular bisector. Okay? Everybody see the tick marks? So a median goes from the vertex to the midpoint of the opposite side. Notice the tick marks. This is what we're looking for here. Okay? From the vertex to the midpoint of the opposite side. And unless we have a situation like Joe asked about with the perpendicular bisectors, notice the perpendicular bisector doesn't go through the vertex. Okay? It doesn't go through that vertex, but the median will. Okay? It goes from one of the angles to the midpoint of the opposite side, so it cuts that side into two equal parts. It bisects it. Okay? This is a median. AD is a median. Cuts the street in half. So far, so good? Okay. Questions on this one? So perpendicular bisector, we look for right angles, we look for tick marks. It has to have both. Angle bisector, we look for the arcs to be cut, the angles to be cut in half. And medians, we just look for tick marks from the vertex to the middle of the opposite side. Okay? Exactly. We have to have a tick between BD and a tick between DC to show that these two are now equal sides. They have equal measures. Or we need to see that this one's 5 and this one's 5. Or that one's 2.7 and that one's 2.7. We need to see some indication that those two sides have the same length. Those two segments have the same length. Questions on this one? All right, next one. The last one we have to talk about is altitude. Now, when you hear the word altitude in real life, you think, hey, what's the cruising altitude of the plane? How high, what is the altitude of a particular mountain? Pikes Peak, what's the altitude? Okay? What happens when I get altitude sickness? I've been too high, I haven't had enough oxygen, and it starts to make me feel ill. Okay? So altitude is not about any old height, it's about the perpendicular height above the ground, or the perpendicular height from one vertex to the opposite side. So we're looking for, again, right angles. So we look for right angles, and then this one happens to have two altitudes, doesn't it? From C to B is one right angle, or from A to BC is another right angle. This one has 3 altitudes here, but not all of them will. Only because it's a right triangle. Okay. Questions on this one? From one vertex to the opposite side, and let's pretend that this is my new triangle. Vertex to the opposite side at a 90-degree angle. Or if it's obtuse, here's an obtuse triangle. Sometimes we can't go 90 degrees to the opposite side, so we drop a perpendicular down this way. We finish it off, and this would be the altitude. Great questions. Any other questions? Okay, so perpendicular bisectors, angle bisectors, medians, altitudes. 4 things to worry about. So what you're doing now is you're going to label 1 through 12. 1 through 12. I want you to look at them and see what marks you have and decide whether they're perpendicular bisectors, angle bisectors, medians, or altitudes. I'll give you a few minutes. I'll walk around, answer questions, and then we'll talk about the special properties that these have. Okay? So we have a point C and a point A, and notice that the distance between point A and C is 8.32 right now. Everyone see that? The numbers are kind of small. And between C and B is also 8.32. Okay? Watch what happens as I move C up and down. Okay? It's 5.71 both sides, right? Good. This is the perpendicular bisector. What's it doing? It's splitting A with AB into two separate parts, and it's making a right angle here, isn't it? Okay? So anything that is on that perpendicular bisector, any point that's on the perpendicular bisector, is going to be the same distance away from those two endpoints of that segment. Okay? That's the perpendicular bisector theorem. Okay? It's not on your paper. Okay? So just showing you in general. Okay? So anything that is on the perpendicular bisector will be the same distance away from both parts of that segment, both endpoints of that segment. Okay? So then the next piece is that we need to know what happens when we find three perpendicular bisectors of the triangle. Before we were just looking at one. But notice that from A to F is a perpendicular bisector. It cut it into two equal sides and has a 90-degree angle. From C, not C, but not A to F, but from G, this point G to F, okay? This point G to E is cutting this segment into two equal parts with a 90-degree angle. And from G to D is cutting this particular segment into two equal parts with a right angle. Okay? This point G is a special point. Okay, it's got a special name. So not only do we need to know those four special segments, but we have to know the name of this. And this guy's name is the circumcenter. Okay? So perpendicular bisector is the longest thing we had to know, and circumcenter is the longest word. So remember that perpendicular bisectors go with circumcenters. This guy's name is the circumcenter. And just like the perpendicular bisector was equidistant from the angle, right, that point, anything on that perpendicular bisector is equidistant from those two sides. Notice that we have this distance is 4, this distance is 4, and this distance is 4. So the perpendicular bisector forms a point G, that is the circumcenter, and that circumcenter is the same distance away from all the angles. Bisect the side with perpendicular bisector, and the points that is formed is the same distance away from the angles. Bisect the sides, be the same distance away from the angles. Okay? I'm sorry. You only have to have 3. Those 3 points are considered, those 3 lines form a point. That's a point of concurrency, and we won't use that word a lot. Instead of just intersecting, they all 3 come together at exactly 1 point. And do they have to have a right angle? Yes. When we make those 3 perpendicular bisectors, these 3 black lines, right, they're going to form a right angle and have a tick mark, right, to show that they're perpendicular bisectors. But the point that they make is going to be the same distance away from all 3 of the angles. Question? That's what we're working on right now. Okay? Or give me just a second. Okay? 7 through 12, we should have been okay. I'll come to help you. Okay? So this is the circumcenter. Everybody good so far? Okay? It's the same distance away from all the angles. It's the middle of the angles, exactly. So it's the same distance, it's equidistant from the angles, the vertices. Okay, cut the sides in half using perpendicular lines, right? And the point formed is going to be the same distance away from all the vertices. So far, so good? All right. So here we go. I'm seeing phones out, guys. You shouldn't have phones out. Okay. Okay. All right, here we go. Next piece. Okay. The angle bisector theorem tells us what happens when we bisect the angles. And when we bisect the angles, I don't know if this is going to work. It didn't work earlier when I tried it. Put this down. Okay. Okay, watch what happens when we bisect the angles. So here's an angle formed by two rays. And if I move this point D, if it lets me, there we go. What do you notice about the numbers? 1.81. They're the same. How about now? They're congruent. Okay, so these segments from that angle bisector, the point on the angle bisector to the sides is the same. So when we bisect the angle, it's going to be the same distance away from the sides, equidistant from the sides. So, important point here. Bisect the angle, it's equidistant from the sides. Bisect the sides perpendicularly, it's equidistant from the angles. Okay, because you're talking about something else. Let's focus. Okay? All right. So here are our angle bisectors. Okay? They have cut these angles into 3 equal parts, and they meet at this point D. From D to the side of the triangle is the same distance as D to this side of this triangle as it is to D to this side of the triangle. These are all the same length. Okay, so that point is equidistant from the sides. Okay, so nope, if I call this guy, I've used FG, if this is H, I, and J, these guys, then DH, DI, and DJ are all the same distance away because of the ticks. Okay? Good question. So the perpendicular bisector is going to be equidistant from the angles. The angle bisector is going to make it equidistant from the sides. They're just flip-flopped of each other. Okay? Bisect the sides, you're going to be the same distance away from the angles. Bisect the angles, you're going to be the same distance away from the sides. Okay? So let me show you what's going on here. Okay? So, angle bisectors, like I said, there's a lot of vocab. You're going to have to study the vocab, guys. And you've got to focus and pay attention. Okay? Angle bisectors are going to meet at a point called the in-center. Angle bisectors meet at the in-center. I did call the other thing a different thing. And in the box. In the box. No, not right now. Okay. So our perpendicular bisector is the big long word. Okay. It's going to make a point in somewhere in the middle, and it's called the circumcenter. Okay. The circumcenter is going to be the same distance away from all the angles. Exactly. So now we've broken the angles into 2 equal parts, and this point will be the same distance away from the sides. Okay? So when you okay. I want to hear those kinds of questions. I don't want to hear the other conversations. Okay? Okay? So when you bisect the sides with perpendicular bisectors, it's the same distance away from the angles. But when you bisect the angles, it's going to be the equal distance to the sides. Okay? And this guy is going to be called the incenter. So we got two more centers to talk about, circumcenter and incenter. Okay? Here's our next vocab word. Remember the medians? Okay? Those medians went from the vertex to the midpoint of the opposite side. Okay? They form a point as well. And that point is called the centroid. It is. This sounds like a Star Wars thing, okay? Centroid goes with medians, okay? Perpendicular bisectors went with circumcenters. They're the great big long words, the longest one. Angle bisector went with the incenter, and the medians go with the centroid. Okay? The centroid is formed by the medians. Okay? Now, here's the cool thing about the centroid. The centroid is going to split those medians into parts that are proportional. One will be half as big as the other one, or one will be twice as big as the first. Okay? So if this GE is 5, then BG will be 10. Or if BG is 24, then GE will be 12. It's because of the fact that the median splits them into, or the medians are split by that point, that centroid. And if it happens to be 30 for B to E, we can still do that because it's going to be 10 and 20. 2x plus x, 3x equals 30. So one of them is 10 and the other one is 20. Okay? That's the centroid. Okay? Now the good news is we have one more word to know, and it doesn't have any special properties that we learn about in the geometry in high school. And that one, that's the good news. We only have 3 special properties to learn. But this one is the name of the point where all of the altitudes meet. This point G is called the orthocenter. Nope. No proofs. No proofs, just lots of no proofs, no more proofs the rest of you. Okay? But there's a lot of vocab. You've got to study this vocab. You have to know this tomorrow. Okay? Okay? All right. So, orthocenter, altitude. Okay? So, perpendicular bisector went with the circumcenter. Great big giant words. Angle bisector, this is right here. Okay? So on the back side, yep, the fourth one on the back side. Angle bisector went with incenter. It starts with an A and has a vowel. Starts with a consonant, has a consonant. The median had a centroid, consonant, consonant, and the altitude, orthocenter, vowel, vowel. So find some way to make these make sense to you. Okay? Questions on this one? Okay. Well, we're going to do number 13 and 14 together to see how this works. Okay? Okay? Brendan, please. I'm sorry. So we're going to write 2 things down. On 13 through 21, or 13 through 18, I want you to figure out, first of all, what made this, what things are connecting at that point of congruency, or that point, and then what the name of that point is, that special center. Okay? So, when we look at this one, We don't see any right angles. We don't see any angle bisectors. We don't see any tick marks. So we have to look at the numbers and decide what's going on. Yes, sir. I want you to do both. Okay? So on this case, he noticed that they're all the same distance away from the side, aren't they? 4, 4, and 4. So if you're equal distance from the sides, that means you bisected the angles. Okay? So this is angle bisector. Okay? So the angle bisectors formed this point G, and G's special name is in center. A went with I. And in center. Exactly. Okay? Questions on that one? Okay? Now the next one, number 14 on your paper, says what's going on here. And I only see I see numbers and I see tick marks, but let's not pay attention to the tick marks. Which one of them had something that was twice as big as another? Median centroid. Very good. Median centroid. Thank you. That's what I'm looking for. Okay? Two things. What segments made this point and what's the name of the point? Not as far as name as in point G, but what is the special center name for it? Make sense? That was 14. Median centroid. Okay. Let me stop recording real quick.